First, open your terminal, and if you are using a virtual environment where you have all the packages installed, activate it. Then, navigate to Zivid Python samples and set the Python path. You can find the instructions on Zivid Python samples main page on GitHub or on Zivid's knowledge base. To find it on the knowledge base, you just need to click on Samples, Python, scroll down to the installation chapter, choose the right command for your terminal. In this case, we are going to use bash. Now, it's finally time to run the script. For that, we write Python, and then the directory of the script, and we need to pass some arguments before running it. So, by writing --help, we can see what those arguments are. Here, we can see that we need to add what type of system we want to calibrate. It's going to be --EIH for eye in hand or --ETH for eye to hand. We also need to provide the IP address of the robot and the target keyword. This target keyword is the name that we used in the robotic software when we save the poses. Let's reuse the last command, and instead of writing --help, we are going to start adding our arguments. The order in which we input these arguments is not relevant. The first one will be --EIH because our system is eye in hand. The next one it's going to be --IP, which is the robot's IP address, the same one used in robotic software. The last argument is the --target keyword. In this case is target. Remember to disconnect the Zivid camera from Studio before running the Python script. It is not possible for two processes to be connected to one camera at the same time. If you don't do it, you will find this error on your terminal. Once the script is running, you can input where you want to save the dataset, or just press enter, and by default, it will be saved in the same directory of the script. The rest of the process is done automatically. While the robot is doing the calibration, I would like you to know that we have different ways to verify the hand-eye calibration accuracy. Check the sample Verify hand-eye with visualization.py, where all the captures are transformed to the robot space and displayed. This way, we can visually inspect the accuracy by looking at how well the point clouds are overlapped. This verification can be done without using a robot. Check also the sample robotic verify hand-eye calibration.py, where the results of the hand-eye calibration are verified by using a robot to perform a touch test.